I want you to follow those calculations very slowly and understand exactly where the numbers are taken from. So at year number 3, we're starting from the par value plus the last coupon, discounting it by the interest rates that we can predict at year number 2, and take the average. We get the valuations on the up, 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 down, and down, down, down. From at year number 2, the cash flows are derived 1 year cash flows as follows. We take the valuation from here plus the coupon. This valuation comes from here plus the coupon. We're discounting it by the same 1 plus interest rates and take the average. This valuation will move to here, that valuation will move to here, and this is how we get this valuation, 99.907, which is right here. Finally, we have one more step to do to take a look at this branch of the tree. We take this valuation plus this coupon, which is here, we take it from here. That valuation plus the coupon, we take it from here, divided by 1 plus the current interest rate, 1.034, take the average, and we get the current valuation. This is the process for any option-free bond. Now, let's embed also the complexity of options inside. Okay? Let's start with a callable bond. We said that a callable bond gives advantage or some protection to the bond issuer. Why? Because the bond issuer is the one that can call back the bond whenever he wants, not whenever the bond holders want, whenever the bond issuer wants. And obviously he will do that only when the interest rate will go down. When the interest rate will go down, then the bond price will move up. This is when the bond issuer will call back the bond, will buy back the bond at a predetermined price. So in fact, the bond's value is the minimum between the bullet bond value and the call price. Remember that we're subtracting, let me go back here, and I'll show you where we talked about it. We're subtracting here the value of a call from the value of a bullet bond, straight bond. This is the value of a callable bond. So in fact, the bond value on each and every node will be the minimum between the straight bond's value and the call price. Why do we take the minimum? If the bond's value, the bullet bond's value, will be less than the callable bond value, in this case, the bond will stay as is. The bond issuer will not call it back. However, if the bond's value, the bullet bond's value, will exceed the call price, then obviously the issuer will call back the bond and will buy back the bond at a predetermined price. So the call price is in fact kind of an asymptote, kind of a cap. The bond price cannot exceed the call price, whatever it is written on the contract. If the call price is said that the issuer is entitled to buy it back at $100 whenever it feels like, then the bond price by definition cannot exceed that price, because whenever it will exceed that price, the bond issuer will buy it back. And therefore, it is kind of a cap. Therefore, we take the minimum between the bullet bond's value and the call price. So this is the decision that we will add to each and every tree, each and every node that we had here. Those nodes on that tree took into consideration only random events. In other words, whether the interest rate moves up or down. Now we will also embed here the call price. The call price, for example, in this story, the call price, if it is 100, then we're doing on each and every node the minimum between the straight value and 100. The minimum between 97.977 and 100 will stay 97.977. So it's not going to change. Same thing here, 99.179. The minimum between that value and 100 stays at 99.179. So the value will not change here. However, the minimum between 100.186 and 100, in this case, the interest rate the call price will kick in, the issuer will call back the bond at $100, and at that point, the bond value, the actual bond value will not be 100.186, it will be 100. So that is the only difference. What you will expect here to see on those kind of trees, for callable bonds, you will see that the decision to call back the bond will kick in more at the lower branches, lower nodes of the tree. Why is that? Because usually on the lower nodes of the tree, you should expect to see higher valuations. Simply when interest rate goes down, the valuations go up. With higher valuations, then the issuer will call back the bond, buy back the bond at a predetermined price, the call price, and this is exactly where the call price will kick in and will make it 100. With a puttable bond, you should expect the opposite. You will see that the puttable price, the put price will start to kick in at usually the higher branches, the higher nodes of the tree. Okay, so just remember the rule, the decision rule on each and every node, if you have a callable bond, will be to take the minimum between the bullet's bond value, whatever we calculated here, and the call price. Just do a minimum, one more step for each and every node, and derive the tree backward exactly as we did before. Let's see one more example here. Let's start once again with the interest rates. So this is a tree that we develop it over 3 years. This is today, this is 1 year from today, those nodes are 2 years from today, and those nodes are 3 years from today. This is a callable bond for 3 years that has a par value of $100 with a coupon rate of 5.25%. In other words, out of par value of $100, 5.25% coupon rate gives you $5.25, $5.25 on each and every node. So the first thing, like we said before, you record the interest rates or the expected spot rates to the future. You start with whatever the interest rate is right now, and then you move either up or down, up, 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 down, or down, down, and that's it. You can stop with the interest rates after year number 2 because they are completely irrelevant at year number 3. We don't care what will be the interest rates on year number 3, simply because over here the bond will mature, and all you care is about the par value, collecting the par value and the last coupon. Once you record the interest rates, you start by recording the valuations. So you start to do that backward. You start from the very far end. Value of a bond is 100 because that's the par value, plus the last coupon, 5.25. V for value, C for coupons. So you record 100 for valuation, and C is equal to 5.25 on each and every node at year number 3. Take a look at the symbols here. This here is using the up, 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 down, 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 and down, down, down on each and every node, okay? N represents a node here. Once we know the interest rate, we start to discount those cash flows backward in time, exactly as we did before. We focus every time on different branch of the tree. So if we'll focus on that branch, you will discount to 100 plus 5.25 divided by 1.06757 plus 100 plus 5.25 divided by 1.06757, and then take a half or multiply by, divide by 2 or multiply by half, same thing. So this is where you get the valuation. This is where you get the valuation here, and this is how you get the valuation here. But the additional complexity here is that on each and every node, you also need to make sure that it does not exceed 100. It is a callable bond, so you need to do for each and every valuation the minimum between the actual valuation and the 100. Over here, the valuation will stay the same because it's already below $100. Over here, same thing. It is below 100 and it will stay the same. But over here, the valuation actually exceeds $100. We got, purely based on the discounting the cash flows from year number 3, we got 100.689. So the minimum between 100.689 and 100 will give you 100. So you cross it and you write 100 instead of that. This is exactly where the call option kicks in. Same thing here, you discount those cash flows plus the coupons using this discount rate, this interest rate, and you record the valuation. You record the valuation here, but once again, whenever it exceeds the $100, which is the cap price, you take the minimum between the valuation of a straight bond and 100, and you record here 100. You cross it and you write 100. Once again, let me remind you that usually the option will kick in, the call option will kick in whenever we are dealing with the lower branches, the lower notes, simply because interest rates is going down here, valuation is going up. This is where the minimum between the bullet bonds price and the call price will kick in. And eventually you discount those two notes back to present time and you get the valuation right now. So this is a story about a callable option that the issuer is able to call back the bond, not at present time, but starting from year number 1. Obviously, if the issuer were able to call back the bond at present time, then the valuation here will not be able to exceed 100. It will also be 100, and instead of 101.432, it will also be 100. So this is a story about a bond, a callable bond with a vesting period of 1 year. So between today and year number 1, the bondholder, the bond issuer cannot call back the bond. This is why we do not cross the 101.432 and we do not write 100 instead of that. So the first year the issuer cannot call back the bond. This is a vesting period, but after that, the issuer can call back the bond. So it is possible that issuers can have some vesting periods. They cannot exercise their either call options here, and we will apply this rule of the minimum between the call price and the bullet price only for later notes.